Today's lesson, 10.4, is on experimental design. So we'll be looking at how experiments are designed to see if they're valid or the best way to set one up so we can get good data from that experiment. So the first type of experiment we're going to talk about is a controlled experiment. And this is where we have two groups are studied under identical conditions, with the exception of one variable. A control group is the group under ordinary conditions. That is subjected to no treatment. The treatment group is the group that is subjected to the treatment. Randomization is a process of randomly assigning subjects to the groups. It's a process of randomly assigning subjects to the groups. So basically, who's being picked to be in the experiment, and then also into which group. Okay. A randomized comparative experiment is where subjects are randomly assigned to the control group and randomly assigned to the treatment group. So in this case, they pick to be in the experiment, but they don't get to pick which group. So they choose to be in experiment, but not which group. Okay. The placebo is a harmless, unmedicated part of the experiment. Okay. So let's now look at these two examples, and we're going to determine whether the study is a randomized comparative experiment. If it is, describe the treatment group, and the control group. So the treatment group, and the control group. If it is not, explain why not, and discuss whether the conclusions drawn from the study are valid. Okay, so here we have baby DVDs improves language ability. To test whether baby DVDs that highlight words and introduce music and art can improve language ability, parents with babies 0 to 24 months were given the choice of whether to let their babies watch the DVDs. 50 babies who watched the DVDs were observed for a year, as well as 50 other babies who did not watch the DVDs. At the end of the year, babies who watched the DVDs scored higher in a language development test. So, is this a randomized comparative experiment? It's not randomized. Because the parents were given a choice as to which group they were going into. Because parents chose which group. So if you think about this, if you choose to put your baby in the group that watches the DVDs, you're probably also the type of parent who's more likely to be working with their child to learn things, right, on a daily basis. So you're doing extra with them compared to the parents who weren't interested in having their kids watch the DVDs. Maybe they just weren't overzealous about that kind of thing. So that variable can really make a difference. We don't know how much more the parents are doing on top of having the kids watch the DVDs. So that's kind of why this would not work. So how would we write that? We would say those choosing to have their babies watch could also be doing other things to improve baby's language. Example 2. New drug improves blood glucose control. In a clinical trial, 100 type 1 diabetic patients volunteered to take a new drug. 50% of the patients received the drug, and the other 50% received a placebo. After 1 year, the patients who received the drug had better blood glucose control, while the placebo group experienced no significant change. Is this a randomized comparative experiment? Yes. They didn't choose which group they were going into. It was random. A drug was given to all 100 patients, and randomly half of them got the placebo one, right? Okay, so that's kind of the difference between a randomized and a not randomized comparative experiment. Okay, let's take a look at randomization in experiments and observational studies. Okay, so when you have randomization in an experiment, individuals are assigned at random to the treatment group or the control group. Okay, in an observational study, when possible, random samples can be selected for the groups being studied. So good experiments and observational studies are designed to compare data from two or more groups and to show any relationship between those variables. Only well-designed experiments can determine cause and effect relationships. So, comparative studies and causality. A rigorous randomized comparative experiment, by eliminating sources of variation other than the controlled variable, can make valid cause and effect conclusions possible. An observational study can identify correlation between variables, but not causality. Variables other than what is being measured may be affecting the results. Okay, so that's for an observational study. So let's explain whether the following research topics are best investigated through an experiment or an observational study. Then describe the design of the experiment or observational study. You want to know whether vigorous exercise in older people results in longer life. So let's think about this. We do an experiment or an observational study. The treatment, which is vigorous exercise, is not possible for those people who are already unhealthy. So it's not really ethical to assign individuals to a control or treatment group. So that would take out the randomized experiment. So instead, we'll want to use an observational study. Once again, if we have healthy or unhealthy people, assigning them to which group, we can't really do that. So it'd be better to just observe these different people, different types of people. Randomly choose one group of individuals who already exercise vigorously, and then randomly choose another group who do not exercise vigorously. So you would observe one group who does exercise vigorously. How do we spell that? And then observe one group who doesn't exercise vigorously. You could monitor the ages of the individuals in both groups at regular intervals. Note that because you're using an observational study, you should be able to identify a correlation between vigorous exercise in older people and longevity, but not causality. When we're analyzing experimental designs, we have to keep in mind that an important part of experimental design is the sample size. Okay, so like for example, in that last one, if I just observed 5 older people who exercise vigorously and then 5 people who don't, that's not going to give me very much information. But if I were to keep observing more and more people, like maybe 1,000 of each, I'd have better results, right? So remember, the sample size is the number of people in the experiment or observational study. Replication is where you have repetition of the experiment under the same or similar conditions. So running that experiment over and over again with other people and very similarly, that gives you a larger sample size and more information to work from. Of the experiment. Under the same or similar conditions. Okay, and this, the replication, okay, improves the validity of the experiment. Why? Well, because you're increasing your sample size, right? All right, for your homework, you'll have some different experiments that you'll be reading about and determining if they are good or not or whatever. So good luck.